Okay, high finance, the formula we're going to be using, anybody going into business classes, this is going to show up a lot. The amount equals a principal, that's the amount you put into an investment, times 1 plus the interest rate over the number of compoundings, close the parentheses, to the number of compoundings times the time. Usually the time is in years. The important information in this is the 13,000, 8.25%, compounded monthly for 35 years. I call these print problems. P, R, N, T. Notice there's no I. The principal equals that big amount that you're putting into the investment, 13,000.
The R is the interest rate as a decimal. And there's a zippy move. All you do is take that decimal point, change it to a decimal, from a percent to a decimal, you move it to the left 2 places. So the interest rate is going to be 0.0825. Compounding. You want to ask yourself, how many months are in a year? So that means N equals 12 because there are 12 months in a year. And the time it gives me is 35 years. Now, the rest needs to be done actually on a scientific calculator. A normal Bobo calculator won't be able to handle this. So if you don't have one, just set it up. You don't have to actually calculate it. I'm going to take this formula. I'm going to put it right down here on the problem, on my information. So I'll come over here and I'll put a parentheses. And I'll put the 1 plus a division bar, 2 and X box. And that's all I really have to remember. If I can write down this stuff in print form, this fraction bar, you see the R and the N? Do you see the R and the N in the formula? So it's going to be 0.0825, 0.0825 over 12. And then up here in the X box is going to be the 12 times the 35. 12 times 35. And now you can just dump it into the calculator. The 1,300 is it 13,000? Whoa, I messed up. There's supposed to be another 0 there. 13,000. Did it again. 13,000 parentheses 1 plus a fraction bar. Put the 0.0825 on top. 0.0825 down arrow. Put the 12 on the bottom, right arrow, parentheses, X box it, raise it to the power of 12 times 35. And after 35 years, if you give them $13,000, they'll give you back a lot more than that. That's $231,034. So the amount you receive after 35 years is $231,034. and 91 cents. And that is a financial problem. So if you deposit $3,000 into a mutual fund, which earns 12.75%, now that's not going to happen in today's day and age, compounded weekly, how much is the investment worth after 20 years? So my principal is the original large sum of money that I deposit, which is $3,000. My rate, notice I moved that decimal to the left 2 places. So it's going to be 0.1275. The number of times I compounded in a year is weekly. So that means there's going to be 52 weeks in a year. And the amount of years that I leave it in the investment for is 20 years. So I'm going to set this up right here alongside the 3,000. So I'm going to do my parentheses, 1 plus a fraction bar to some power. I'm going to fill in the information. Notice it's R over N. In the formula, I have R over N. So I do this R over this N, 0.1275 over 52, 52 weeks in a year. And now I have to do 52 times 20. That's my NT up there. So I'm going to do 52 times 20 as my exponent. And you have to remember to raise it to the exponent. Calculator key in. $3,000, parentheses, 1 plus, fraction bar, 0.1275, down arrow, 52 weeks in a year. Then you have to Xbox it. You have to hit that button and raise it to a power of 52 times 20. You give them $3,000, and then they give you $38,000. $38,301. So the amount after 20 years is going to equal $38,301.58. Again, we're going to use A equals the principal times 1 plus the rate over the number of compoundings per year raised to the number of compoundings per year times how many years. So another $13,000 problem into a tax lien fund. That will earn you about 10% in today's market. Very good fund. How much is the investment worth after 20 years? I think I'm missing something. Compounded daily. So how many days are in a year? Those are the bits of information that we need. So the 13,000 is my principal. I'm not going to forget that zero on this one. The rate is 10.4%, so I move it over. So that's going to be 0.104 as a decimal. Compounded daily. In the banking calendar, there are 365 days in a year, and they want it in there for 20 years. I'm going to set up the formula, parentheses, 1 plus a division bar raised to a power. The R over N. The R over N is 0.104 over 365. The NT is 365 times 20. Calculator key in. $13,000, open parentheses, 1 plus the fraction bar, 0.104 on top, down arrow, 365 on the bottom, right arrow, close parentheses, and then raise it to the 365 times 20. And you originally give them $13,000, and let's see how much you get back after 20 years. That's $109,642.18. So after 20 years, the amount you have is $109,000, 642.18. All right, you deposit $43,000 into an REIT, a REIT. That is a real estate investment trust, which earns 17.5%. And yes, that is an actual percentage on these types of investments. Compounded quarterly. That means N is going to equal 4. The years is 15. How much is the investment worth after 15 years? So the principal amount that I invest is $43,000. The interest rate is 175. The number of compoundings is 4. Quarterly is 4. And the amount of years is 15 years. We're going to implement this formula, a parenthesis, a 1 plus a fraction bar, and then we're going to raise it to a power. The R over N goes on the fraction bar, 0.175 over 4. Then I raise it to the NT, that's 4 times 15. I could have done that in my head, but I'm going to keep it in the calculator. Hit equals, and this is a nice one. You get $500,000. You invest $43,000, and you get $561,000 when you're all done. Not bad. A equals $561,000, 381.07.
Okay, welcome to real estate finance. You take a $350,000 30-year mortgage. That's a loan on a house. It's called a mortgage at 3.5%, compounded annually. Yes, mortgages are usually compounded annually. How much do you pay back at the end of the 30-year loan? So in other words, do you think you actually pay $350,000 for that house? So the loan amount is for $350,000. The interest rate is 0.035. The number of compoundings per year is annually, so that's going to equal 1. And the T in years is 30 years. Going to use our formula, 1 plus fraction bar. The R over N is 0.035 over 1. And then 1 times 30, I can do in my head, is going to be 30. We're going to enter that into the calculator. $350,000, parentheses 1 plus fraction bar, 0.035, down arrow, over 1, to the 30 years. So $982,000, almost $1 million. At the end of the loan, you will have paid $982,000. We're going to do another part to this question. That was part A. Part B. What is your yearly payment? How much is this house going to cost you per year? So I just take that and I divide that number by 30, because that's how many years the loan is for. So I'm going to take that value, I'm going to divide it by 30. That means the house payment is going to cost you $32,745.93 per year. That's not your rent. That's what it costs per year to live in this house. So when you go to the bank for a loan, the first thing they want to know is how much you make a year. And they do this arithmetic while you're not looking to say whether you're approved for the loan or not approved for the loan. So you have to make 4 times that in order to afford that house. That's a little real estate rule of thumb. You're only allowed to pay 25 or 26% on housing of your total income. So if you make $32,000 a year, you're still not allowed to buy that house. They won't loan you the money. They'll let you buy the house if you have the money, but they won't loan you the money for the house. C is what's your monthly payment. That would be your mortgage payment or your rent. What's your monthly payment? So all
I need to do now is take that number and divide it by 12. So it costs $2,728 per month. Pretty expensive house. $2,728.83.